we are fortunate to have Dr. Russell Gersten with us today. Dr. Gersten is the Executive Director of the Instructional Research Group, an educational research institute in Los Alamitos, California, as well as Professor Emeritus in the College of Education at the University of Oregon. He recently served as a member of the National Mathematics Advisory Panel, co-chairing the Instructional Practices component. He currently serves as the Principal Investigator for the What Works Clearinghouse and chairs the panel developing practice guides in response to intervention in mathematics and reading. He has written extensively about early intervention in mathematics and valid assessments for screening students who require additional help in learning mathematics, and has conducted meta-analysis on effective instruction for students struggling to learn math. We are very fortunate to have Dr. Gersten, who is sharing his experience and his expertise with us today. So now I turn the presentation over to Dr. Gersten.
Good afternoon, everybody, and I'll give you a quick overview of what I'm planning to do and focus on. As Whitney mentioned, we're going to have a couple of times for questions. And what I'm going to do this afternoon is just give you a thumbnail sketch of the half-dozen or so important areas to consider in either initiating, refining, moving forward with RTI and math. And it's going to follow the structure of the RTI practice guide in math. And I have the web address, which is at the end of the presentation, and you can download it for free. I want to talk for a second about what practice guides are. I first quickly want to show you, the co-panelists who helped us put this together. What we tried to do is mix both the professional and expertise of both people in the field and researchers and mathematicians with the actual database. So what makes it a little different than other publications is that we are very clear about how much evidence there is behind each of the recommendations we make. And the group here includes, let's see if I can get this, a mathematician, former school psychologist with an assessment background, Ann Fagan, who has a big math ed and special ed and assessment background, a math coach who's now an assistant principal in Maryland, more of an ed psych, cognitive psych person who does a lot with middle school math, and Brad Witzel, who does a lot in math interventions for LD kids and has a forthcoming book on RTI and math coming out. The practice guides, for those of you who aren't familiar with them, and they haven't been disseminated as widely as I think they should be, they basically have, in this case, a set of 8 recommendations, some ideas about how to carry them out, and we tried to make them as practical as possible, understanding we're dealing with the reality of all of K-8. So this is not a detailed procedural manual, but is an idea of how, as a math coach, building principal, special ed teacher, member of a school team, leadership team in terms of RTI, the kind of things you might want to think about, and then gives you some ideas of ones you might want to prioritize. It is different than others in that we have impartial people, the contractor, mathematical policy research, CODES following a strict format, so only those studies that are valid, experimental or quasi-experimental studies make the cut, and then we talk about potential roadblocks and make some suggestions for how to address them. The research evidence, what we did here is we focused for the levels of evidence on the high-quality experimental and quasi-experimental studies, and they were examined under a fine-tooth comb using the criteria that IES has established for basically for large-scale research and evaluations. We also, for screening and progress monitoring, looked at the measurement research, not in the amount of depth and detail per measure that the RTI Center is currently doing in their reviews, but we definitely looked at the body of research. In terms of qualitative and descriptive studies, including any multiple baseline studies, they were used to help us shape and frame our recommendations, but they are not counted as evidence. Then, based on this, we rate things as strong, moderate, or low. Low does not mean it's a bad idea or they're negative findings. Low means there just isn't any research yet on it, either because people just haven't prioritized it, sometimes because there never was a standalone on that component. Motivation is an example. Several of the valid, high-quality gold standard studies had a motivational component, but there were also so many other things going on, we couldn't conclude that there was any evidence supporting the use of motivational systems. So we just said, this is our belief as a panel, this is our consensus. Moderate means there's at least one gold standard or a couple of pretty good studies supporting it, and strong means there are 3 quality studies supporting it. Now, strong still doesn't mean it's been replicated around the country, but at least there's some evidence something must be on the right track. Because, again, these are gone through very, very thoroughly for methodological criteria. Probably, given the context in the center, I'm not going to spend any time on the key principles of RTI. Probably some of you know these better than I do, but they're just listed here. And I think at this point it is time for the poll. Is that correct, Whitney, Hillary, Adam? I think.
Pardon me, Dr. Gersten?
I think this is time for the poll. Adam, is that correct?
I'll open it up.
Yep. And there are just 2 questions. If you just fill them out, it should take you about 20 seconds. It just gives us a picture of where we are. Okay, polls are closed, and what this is, in the scheme of things, a sophisticated audience in that the most popular option with about a third of you is that you have some interventions for struggling learners at some grade levels, and then about a sixth say you have reasonable implementation of RTI in math. So we get a whole spectrum, but this is always good information for us to have. And we'll try to at least, I'll try to point out how the different parts of the guide can fit people at all the different levels. Should we do the second poll item?
Yep, I'll bring it up right now.
Yeah.
All right, the polls are closed.
Okay, and I'll tell you the reason I started doing this question is a lot of us who love math kind of like, you're very closety about it because you're around people, it's especially true in elementary education, and they invariably say, you know, I'm not good at math, I don't understand anything, and it just becomes kind of a norm, and it's kind of nice to see a group where 3/4 of the group like mathematics and virtually half of you love math, because it's kind of nice to build a community and also to ever so slowly try to have an impact on the broader education community so that math is valued at a level other cultures seem to do it more, that people don't, in other countries, brag about not being good at math, which here sort of a lot of people do. No one does it about reading. If you're not a good reader or whatever, it's shameful and humiliating, but math people feel very comfortable about it. But it was just a way to get a sense of where you are. This is the triangle, which depending on which state or district you're in, some people never want to see it again because they're so sick of it. These numbers I put in here, these are based on some prevalence estimates, but one is from Israel. They're really rough estimates, and there are likely to be some grade levels where and or some schools where the tier 2 percent may be a lot higher than the 15 to 25%. This is, I think, can be true in some middle schools especially, where there's a huge interest in interventions in RTI and math. So nothing thrilling here. This is a quick overview of the 8 recommendations, and as you could see, the levels of evidence go all over the place. We think they're all important, but what I'm going to do is give you tidbits of each of these and talk especially about the evidence, because that is important for you to know, as well as what practical tips we could come up with. First recommendation is screening, and we said the evidence is moderate. It's pretty strong in the primary grades, especially K and 1, and then it's kind of okay. There are a few studies here and there, a lot of holes, and I'll get to those in a second. What people do in K and 1 is 2 kinds of things. One is they look at one aspect of number sense or number knowledge, because a lot of the work of K3 is building knowledge of whole numbers, operations, the properties of numbers, and understanding how to do word problems, how they fit on a number line, etc. So of all of the measures, our magnitude comparison is the one that probably has the strongest predictive validity if you're going for a quick measure that takes a minute or 2. Some measure involving not just actually counting, but asking kids, and I'll show you an example in a second, what I call strategic counting, seems very important in K and 1 because it's linked to basic proficiency and understanding of the properties of the number system and what addition, subtraction are. Grades 2 and up, we mainly have the work of Lynn Fuchs and her colleagues to guide us, and what they've tended to do is take a sample of items from the whole, let's say if it's a group of 4th graders, the grade 4 state standards, and sample those standards. And because they're in Tennessee, they took Tennessee standards and use some of those measures, paper and pencil measures, beginning even in 1st grade, and they take 5 to 10 minutes and use those as a predictor. And it's come out okay in the scheme of things. So we see that as a potential framework for those of you either developing measures or looking for measures, with the understanding that the research is still emerging there. This is an example of what we call sometimes missing number or strategic counting, and you could see where this top example could be a little tricky for kids, where the bottom example, 9, 10, kids are going to know 11, or many of them will know 11. Sometimes in kindergarten they won't. And this one is probably, the middle one would be the easiest, but this takes the ability to really be fluent with counting and be able to go backwards as well as forwards. So measures like this are just quick snapshots for initial screening. Magnitude comparison is something that the late Robbie Case thought was critical for learning math, and basically the development of a mental number line, and there's increasing research showing how important this is. And so this is one quick way to tap this kind of knowledge. And at least in K and 1, and the actual numbers you use would vary. By second grade, you'd probably want to go into, it's really more a measure of place value, and really seeing if kids understand place value. One thing we have in the practice guide are roadblocks, and I just put this up as an example. This is a huge issue, and we're aware of it in reading. The same seems to be true in math, that there is a lot of false positives in kindergarten and first grade. A typical theory or rationale for that is that the playing field isn't level. Some kids have a lot of number work in preschool. Some kids didn't go to preschool, didn't get it at home. So the idea is that as kids are in kindergarten and again in first grade and surrounded by numbers and counting and whatever songs or games involving numbers or other activities, they're going to get better at it. So that a measure by November or so might well be a much cleaner predictor, what we call, the technical word is specificity for that. I think here, ideally we'd have audience suggestions, but if people have them, you may want to send it in as a question for this other concern that screening, and I've heard of this happening where you could have a 5th or 6th grade class where 17 out of 23 kids are below benchmark on a screening measure. So if people have ideas what to do, you could type them in and send them to Adam and Whitney at AI and Hillary at AIR, and we can see what you came up with. All the rest now are going to deal with Tier 2 and Tier 3. Okay, so it's our famous triangle. What to teach. Notice in the bottom, the level of evidence is low. This is based only on expert opinion. And in terms of what to teach kids in intervention, this is what we came up with, and this is where the role of Sibylla Beckman, the research mathematician, was critical, that the core is number. You want to teach kids everything you can about number, the properties of numbers, obviously computation, word problems, how they fit on a number line, estimation, and the idea is whole numbers in K through 6 and rational numbers in grades 4 through 8, if possible. Now, it looks like in grades 4, 5, and 6 you do both, and that is exactly correct. You would do both. But the key thing you would do is spend most of your time on numbers, so you wouldn't want, in an intervention, something that does a little bit of probability, a little bit of statistics, a little bit of whatever. You want things that really teach in depth concepts about whole number and rational number, which means essentially fractions, decimals, ratios, because that way you're getting kids ready for algebra and you're building a sense of abstraction in the students. The evidence was basically our opinion, but we're influenced by the National Math Panel, the NCTM focal points. This also seems aligned with the course standards that are being written, at least the draft standards as we speak, and will be out in January. International comparisons tend to show that very high-performing countries really hit number concepts, properties in incredibly intense units that are intense. I mean, they're not boring necessarily, but they are, there's a lot more time and attention, and there is a real push to get kids to move towards abstraction with the understanding math is always going from the concrete to the abstract. We made the leap, and we're influenced by an important paper by Jim Milgram and Professor Wu at Berkeley. So we made the leap to that for intervention curricula, it's even more important that you focus on these key critical topics. Even thinking of geometry and measurement more as, in many cases, applications of number, you know, that basically where kids tend to fall down isn't knowing what's a circle, what's a triangle, what's something, if any of you look at a program like Singapore Math, you'll notice right away that it involves procedures, concepts, and word problems that are linked together, and they're kind of always linked together. And that way of teaching seems to make a lot more sense. Less time is wasted, too, because rather than, like an example, you learn the formula for an area of a triangle and you compute the area for 12 triangles. Well, not that much math is going on. It just becomes an arithmetic lesson done in maybe 5th grade or so, where the idea here would be you're really working on building the knowledge of the mathematical ideas or concepts tied in with the procedures and always word problems. Number properties is what, back when I went to school, we called the laws, the commutative property, associative, and distributive. And some of you probably know this in your sleep. Others, I had this somewhere in high school. But these are just basically what they look like, and basically they're at the root of arithmetic. They're the properties of whole numbers, and what you want is kids to know these like the back of their hand. So like you could wake them up at 2 in the morning, and they could not only tell you what the distributive law is, but show you how it applies to multi-digit multiplication or whatever. That this is the key language of math, of beginning math. And what I'm seeing now is textbooks will often have some material on this, but it might be a day here and there. And this, in an intervention, needs to be a core part of that for kids to understand what math's about. These are definitions of fractions, and I think this is just more in there, and these slides will be downloadable from the center's website, is just the idea. What we usually do with kids with fractions is we kind of tell them it's part of a whole, like it's, they're 8 slices of pizza, so, they're 8 slices or 8 pieces, so it's 1/8. If you have a pizza with 6 slices, it's 1/6. But then you have this problem so you tell them it's part of a whole in 3rd grade, but then you're suddenly going, 2/3 of the houses in the neighborhood, we look at under the 2nd bullet, 2/3 of the houses in the neighborhood have wooden shingles. Okay, there are 15 houses in the neighborhood. Well, and they're going, wait a minute, what is this? You told me it was part of a whole. What does this have to do with pizzas and whatever? And so if you go to mathematicians or books written by mathematicians, you get a much better definition of what a fraction is. So basically that's the middle definition. It's, that all of that we tend to use the word of, but that's not a formal mathematical definition, but all fractions represent part of either an object, which is the pizza pie, a collection of objects, or a quantity. So you're basically, and this is in Beckman's textbook for Math for Elementary Ed Teachers, which is as useful or more useful for special ed teachers, but you're basically giving kids a definition that's useful to them so that they can figure out a whole array of math problems. Now, the thing is, how do you explain this to 9, 10-year-olds? And that is what's the art of teaching, the art of clear curricula. But these are exactly the kind of things you want to look for in a good intervention curricula. And you want to think about in terms of teaching students in intervention, because you want to give them accurate, precise mathematical definitions. And some of it involves making sure you as a teacher or your teacher team understands some of these, the mathematics that underlies this. And there are various ways to do that, and we're beginning to see that the knowledge that a teacher brings of math does correlate a little bit with the gains their students make. So that is an important issue. I think now we're going to take a little break for questions, and we're right at the halfway spot. So just type in, and then Winnie will read a few of them, or any ideas about what to do if you have 18 of your 23 kids in 5th or 6th grade needing help.
So, Dr. Gersten, we have a few questions if you'd like to
Sure.
stop for that. So, when you were talking about the roadblocks a few moments back, one question said, great point on the roadblocks. Would you suggest that a better screening time for next year intervention starts would be during this spring's benchmarking as opposed to waiting for the fall assessment and forgetting over the summer?
I could see a combination of the two being better, because very often if you have two pieces of information. So I think that would be my suggestion, to use both, because usually you'll have, after the 2nd grade, you'll have the state assessment, and also adding in the more current but briefer screening data would seem a good way to do it. Have another one, Whitney?
Sure. Another question that we got was, my school district, this is one that was emailed to us ahead of time, my school district just began implementing RTI this school year. This year we focused on reading and behavior at tiers 2 and 3 interventions. Should we begin implementing math tiers 2 and 3 intervention programs this year, next year, or wait until reading and behavior are on solid ground?
I mean, obviously it depends a lot on the situation, but I would probably start doing something in math, probably not all grade levels, but trying something. And whether to go with the younger grades or the higher grades, I don't know. In some cases, people like going with the higher grades because of this concern of getting kids ready for algebra and the understanding. The roots of that really are in the elementary grades, especially the upper elementary grades. So I'd recommend doing some things in math, maybe doing it in a limited scope. Also in math, you will find less quality off-the-shelf materials than in reading, given the way the field has developed. So I'd recommend giving it a start, though.
Okay. Thank you. One more.
Okay.
Does the universal screening for math need to be a research-based assessment, or can it really be a teacher, school district, pencil paper assessment? There are many research-based assessments for readings, for example, Dibbles, Fontes, and Pinnell. Do we need such a recognized test for math?
Okay, this would be my sense. Right now, the person who submitted the question is correct. There are not a lot of great off-the-shelf measures. I think it would be fine to do something analogous to what Lynn Fuchs did, to look at your annual, state standards and objectives and develop a measure. But what would be great is if you could work either with a local university or your research and evaluation department and see how well it predicts, and also have someone who has some basic knowledge of assessment, psychometrics, do an item analysis so you can refine the measure. So this would not be a big budget, heavy-duty test, because I think quite a few districts are doing it for that reason. So it's okay to do it, but be aware it's going to need some data to help refine it, and it is doable. It is doable, and there are a lot of people around who have that skill who can help with that. Okay. So I think with that, we'll go back to the presentation again. We'll stop about 8 minutes before the end for more questions. Okay. Recommendation 3. Now we're getting more at the how to teach, which is nice because we have more experimental evidence on all of these. the key thing is, and when I really went back to the actual studies and went through them, they talked a lot about being explicit. But if I had to pick one thing about the studies that successfully helped either students with diagnosed LD or this at-risk group of kids, because it was more limited, the number of RTI studies, as we were reviewing the research a year and a half ago or so, because RTI is pretty new, especially in terms of math intervention. But the key thing that came out is that the instruction needs to be systematic, that it's not, that you do not drop things, that they're reviewed. And in terms of looking at curricula programs, I think it's nice if they have these a lot of explicitness and a lot of worked examples would be great, because the newer research is showing, at least for kids, let's say grades 5 to 9, huge advantages to using worked examples, contrasting examples, so sometimes kids can then refer to them instead of just having another student go to the board or do something on a whiteboard and work a problem, to have very nice models of proficient problem solving. But kids need those models, but they need a lot of systematic work, because some of the acquisition of proficiency in math is just using it a lot, counting backwards a lot, subtracting, applying subtraction to word problems, applying it to a number line, applying it even to board games for young kids. And so it's just this amount of practice, and there's some data from a first grade RTI study showing that just giving kids who on the initial screening were very low and who were not benefiting much from core classroom instruction because they lacked the foundational kindergarten and preschool knowledge of numbers. Just having a practice counting, subtraction, practicing that 9, 10, 11 thing, practicing counting in the teams, linking it to computation and getting a lot of feedback seemed incredibly important. The icing on the cake and the things that make for elegant interventions would be the models of proficient problem solving, verbalization of thought processes, having kids talk about what they did. And I'll show you an example of that. And giving them a lot of feedback. So you don't want the situation where kids are asking for help. You want to create smaller problem sets and give them feedback, and that is the core. And then frequent cumulative reviews. So sometimes it could just be going, if you're using just a regular core textbook, it's just practicing some of the problems they had 3 months ago to make sure. So if you know fractions is coming up, you want kids to be reviewing some of the work in multiplication and division. So those are some of the things you could start doing in interventions. So those are the key principles and key things to look for as you look at materials. We found 6 randomized trials, and of the 3 things, this is the one that seems the most critical to me, number 2, which says, let students provide a rationale for their decisions. Let me show you what I mean. This would be a somewhat typical response. This is a very frequent error for 1/2 plus 1/3, and they do 2/5. Okay. And then the teacher could tell them they're wrong. The teacher could do it the right way for them. But what you want to do is ask kids how they made the decision to add those together. And because if they're always aware, they're good, because they probably did this because it's the quickest thing to do, but you can also remind them because you're using a lot of visual representations, which we'll talk more about. So you're always reminding them, and they're seeing a lot of things like this. So they'll occasionally get just a straight computation problems, but first they see this much more prompted thing, and again, the degree of prompting in an intervention depends on where the students are, and you want to fade them out and also have kids more and more create them. But initially, I prompt this pretty heavily, so you know, that rather than just tell them, no, you do this, they kind of, you remind them of this idea here, which they're used to doing, especially if they've experienced something like Singapore math, but even beyond that, that they're used to doing this kind of thing. And so that's the idea that kids are always making decisions, and the curriculum and the interventionist are helping kids by having these kind of prompts that show that computation is always linked to you know, to mathematical ideas and things like this, and also that kids can, towards the end, create the prompts themselves. Here's a roadblock that comes up. Some of the intervention curricula you use, which you may be limited by budget to just using a core textbook, they may not have the explicit instruction and may not have enough practice and review and the cumulative review. And all I could think of is, or our team could think of is, you know, it's certainly possible if you have a large district that's using whatever program, hold, connected math, whatever it is, to develop guides so they're just additional problems that go along with it that are shared among personnel in the district that cover these key topics that I quickly talked about. There's another one we got strong evidence on, which is nice. I think if we had done this 5 years ago, that would not have been the case. What kids need to learn, and it's the way few of us learn math, is for word problems, that they learn that there are common underlying structures. Now, some of you are probably wondering, what in God's heaven does he mean by common underlying structure? Well, this is the key insight, that instead of giving a word problem and saying, tell me, is it addition or subtraction, because this was done on the more basic addition-subtraction problems, you have this new middle step about how to analyze a word problem. And you say, and these are two types, there are other types, but a lot of them have to do with quantity and change over time. So you turn your kids into analysts. Before they're doing any computations, they're analyzing. So they see a word problem, and then they say, is this dealing with quantity? Is this dealing with change over time? And then there are different figures and schemas that they can use, and this is one that comes from Singapore, which is a good one, strip diagrams. But basically, by knowing, analyzing the problem and then doing a figure like this for this thrilling problem about the 21 hamsters and the 32 kittens, they get used to, once you analyze it and you use this kind of thing, so rather than the broad way that many of us learn, then you figure out what kind of problem is it and what information do you have, and you write it out verbally. You're starting to create a representation of the problem because you've analyzed it as a quantity problem, and then you have a way to map it out and think about it. And of course, you're setting the stage for the kind of problem solving that kids will do in algebra and physical science, etc. Next. Some of the newer research, and these, of course, are no surprise, is that if there's extraneous information or the wording changes, especially kids in intervention will tend to struggle. And this is why, by having kids live these common underlying structures or schemas or whatever you want to call them, that they'll be thinking about their analysis of the word problem. So they'll learn that there can be irrelevant information in there. They'll learn that concept, and if something doesn't fit in there, they'll be used to giving as their reason for the decision. This is not, this is not relevant to here's my structure. This is really a quantity problem, and I don't care how old the boy is who's in the pet store, because all I care about is the quantity of animals. I just don't, it's not relevant to my problem. It's irrelevant. And the same thing with wording, because they'll be rewording problems anyway. And so the idea that there are intentional instruction in this, which, because these are the items kids miss on tests, and also, could miss throughout their lives. Visual representations, we found moderate evidence. And I think the research on this is just beginning. It's very exciting. It's critical. These include the number line and include other things. These are the same strip diagram that you saw before, but it can also be used for fractions. And I think here you could just see how it could be used for fractions, but it can be used for all kinds of problems. But again, it's a practice in using, and there are ones with circles, there are really colorful ones, drab, but quick and easy ones. But the idea that kids are representing a problem and analyzing the problem before they get to the computation. And these visuals seem useful. Another insight we got from Brad Witzel's research and Cecil Mercer's earlier research is this. We usually have this rule: manipulatives are used, elementary school, middle school are not used. I mean, it's a rule, it's a tradition. What Brad found was if you expeditiously use concrete manipulatives, so these would be kids, maybe 7th, 8th graders, even 9th graders getting ready for algebra, some special ed students. Usually in algebra and pre-algebra, you tend to more do the visual representations, often graphs as soon as possible, and the equations or symbols. But you leave out that concrete phase. So what he does is he expeditiously does that so that kids understand the visual representation. And we have a figure that illustrates it, but it lost something in translation. See, the ones on the left it's really a photo that as it got shrunk, it lost. Those are actual popsicle sticks, basically, that are used, and then kids get used to the visual representation, and then they do the abstract kind of thing. But the basic idea is you just use them very, very quickly, and they really work wonders. Facts. There is a tradition that you hear a lot about, that some schools feel that facts are, kids should practice them at home, but kids should really be doing, concepts and problems in school. Well, for students, this is one of the bedrock findings. Students with learning disabilities in mathematics almost invariably have huge problems with accurate, quick fact retrieval. So working on it, and we said 10 minutes a day. It depends how long you have. You might only have 25 minutes. If you have 45 minutes, you have more time for it. But just basically every day building facts, whether it's done by computer, with flashcards. I mean, there are a lot of ways to do it. And I'll talk a little about the research. So we have moderate research there. One thing you want to do for younger students is help them count efficiently so they can, instead of having to, first of all, so that if they have to do facts to figure them out on their fingers, they're doing it efficiently so that they know, for example, if it's 2 plus 11, since because of our commutative law, that's exactly the same as 11 plus 2, they can just count up in their head from 2. So they can just go 11, 12, 13, and the answer is 13. So they become much more efficient, much more accurate, because they're using this counting up strategy, taking advantage of the commutative property of numbers. And basically, that would be it in grades 2 to 8. Deriving facts in their head by basically using the distributive law of number families is another way. You might ask, which is better, this pure fact retrieval on the computer, or flashcards are doing it more strategically. The answer is it's unclear. There's not like one is vastly superior to the other. That's probably the most honest answer. My suggestion, and what the panel lean towards, is probably doing both would be good, especially for older students when you get, to multiplicate, and even for younger students. So they're both just practicing getting automatic with it, but also seeing how this is relating to increasingly efficient computation. Last two I'll be very quick with, because we have only 3 or 4 minutes before questions. Monitoring the progress of students receiving supplemental intervention. We said the evidence was low. Why did we do that? Though there are some studies that showed that there are reasonably valid progress monitoring measures. So we think it's a promising idea, but there isn't much research there. And also, another problem with the evidence is when we read the actual intervention reports, they were monitoring kids' progress using either the unit test, or many had daily checkouts to see if kids were ready to go on. They were not using the kind of progress monitoring that people are used to in reading from Ames Web or Dibbles or other measures of fluent oral reading. Our suggestion, though, and this is given the low evidence, is you want to probably monitor the progress of 3 types of students in your school. It's certainly great if you can monitor everybody. If resources are limited, your students in Tier 3 and Tier 2, because this will give you a picture of how all the pieces of their program, because you might have a kid who's in their core math instruction, in a Tier 2, more of a support group, but then has some special Tier 3 time to really go back and fill in holes in her math knowledge. And you just want to see how this whole mosaic of things work together. So we said once a month. If it's at twice a month, it's better in terms of getting an accurate slope. And also certainly using what I'm calling curriculum embedded assessments in intervention materials. Is why not use them? You have small groups. It's pretty easy to score them or see how kids are doing, so there's no reason not to use those. Including motivational, we wish we could have said, like the National Math Panel, that this is critical. We all felt it is. We noticed from some of the work done by cognitive psychologists that there's many of the kids who have pretty serious problems in math also have attention problems. And so for that reason, we thought work with, motivational, if it's points, happy faces, whatever, there are all kinds of little things, would be good for older kids. There are ways they can check their own graphs and monitor their own progress. But we couldn't find any hardcore research. And one roadblock is saying it's going to kill kids' interest in math, and there's no evidence that it does. And I think now I'm going to open it up for questions and give you maybe a minute or two, and then Whitney can start with the next 7 minutes, any questions that come up. And I'll show this. This is a resource thing just for folks to look at while you're thinking of questions, and I'm answering them.
Okay, so we have had a couple come in. One is, would you agree that early numeracy screening in kindergarten is okay to do in September, provided interventions are held off for at least a couple of months?
That could be good. I'd recommend doing it in November, though, because if you're going to hold the interventions off, why not, hold the assessments off or like to late October or so. The other thing that could be done is just, and I think the questioner is getting at that, is in differentiated Tier 1 instruction, the kids who in your September screen seem very weak, it could just be 8 minutes where they're just doing some additional practice and counting or even board games to work on understanding number lines and that kind of thing. So I probably still do the assessment in November. We're doing a study this year and seeing if we can up our predictive validity and what's called the specificity of the measure by doing it in November. So that's a reasonable way to go. But I think the whole idea is not to be setting up all these one-semester groups starting with the September screen.
Okay, thank you. The next question is, when explicitly teaching or modeling problem-solving strategies, how do you reconcile the research done with cognitively guided instruction in which students at different levels use different strategies, such as direct modeling, counting on, or derived facts? Is this where pre-assessment comes into play?
I think that for interventions, that would make a lot of sense, that these screens are just screens. It's like in medicine, blood pressure, cholesterol level is just an initial screen, and then you look for more. So, yeah, I think pre-assessments would make a lot of sense. And even including, you may want to, for interventions, pair kids across classrooms if that's feasible, so that they're a more homogeneous group for the small group instruction. Yeah, so that's excellent.
Okay, here's another question that is, what would the recommendation be for a building whose at-risk students exceed the available teacher resources? Who would interventions be directed to first?
And that's kind of what I was asking that one roadblock. That is a dicey issue. There are two ways to approach that. One is, if you see, like that case where 70% of your fifth graders are coming out really low on your beginning of fifth grade screen, one approach, and maybe you could do both, is at once. One would be, well, something is missing from the fourth grade Tier 1 instruction. So you might want to really work with the fourth grade team to see what is missing. What are the skills that the students lack, which could come from the state assessment or from the screening measure, or a combination of the two. And so that would be one way to really move in a preventative way. And it could be, for example, too little time is spent on problem solving or on really serious work with fractions. Some programs go through it much too quickly. The second thing would be, I'd probably start with the neediest kids, because the one thing I would not do, and I heard of a school doing it, is have a quote-unquote small group instruction of 17 students, because it's a joke. It's not what it's intended to do. So I'd probably do both of those, start with the kids who are really at the low end to give them some support as almost like a triage, and then really try to look at what might be root causes in grades 3 and 4.
Thank you. So we have time for one, maybe two more questions. One is, do you have any suggestions as to good places to find math interventions?
Because we're operating the center as a federal grant, we can't recommend specific interventions. You can look at the What Works Clearinghouse, because those are impartial technical reviews of evaluation reports, The only downside to that is you're not going to find that much. I think they've begun to look at math interventions. I'm pretty sure there's some. Beyond that, I know some are around, and I would just look either at, publishers' catalogs. I don't know, and Whitney, you may know what the center does if they are thinking of providing some resource there. I know they may be prohibited by federal law.
The National Center on Response to Intervention is doing a review of interventions that will happen in the coming year in 2010. So there will be a tools chart of interventions within this coming year.
So that would be great. So I would trust them, and for now, I think just trying to use some of these principles and seeing if they're present or absent in what's around. I know you'll run into, especially as kids get older, a lot of technology-based things, and basically the verdict is out on them. There's only one, and that has been reviewed in the What-Worth Clearinghouse, that has had consistent, strong effects, or significant effects. So, it sounds like it's forthcoming, but I can't give you an answer now.
Okay, thank you. Well, we have reached our time, so we'd like to thank Dr. Gersten for sharing his presentation with us today.
Thank you. Bye-bye all.
If you would like to print a copy of the PowerPoint slides from today's presentation, you may do so by clicking on the small printer icon at the bottom right-hand side of your screen. This will allow you to print the PDF, and the slides will also be available on the National Center on Response to Intervention's website, which is www.rti4success.org. If you have additional questions about RTI and math, please feel free to email them to us at rtiwebinars@air.org. I would like to invite you to join us for our next webinar, Interventions in RTI, that will be on December 9th, 2009 at 2 p.m. Eastern Time. During this webinar, Dr. Erica Lemke, Professor of Special Education at the University of Missouri, will discuss primary, secondary, and tertiary interventions within an RTI framework. The examples discussed will primarily focus on the 5 components of reading at the elementary and secondary levels. Some information will also be provided regarding strategies for math. We would appreciate your feedback about today's session. Please take a few minutes to complete the webinar evaluation that you see on the screen. We value your feedback, and ultimately your suggestions will assist us in making decisions for future webinars. Once again, thank you for participating today.